Let's work on this problem. It's on thermochemistry and calorimetry. We'll do a few problems here, okay? So this is the first one. Calculate the heat capacity of an aluminum block that must absorb 629 joules of heat from its surroundings in order for its temperature to rise from 22 to 145 degrees Celsius. Now, the first thing that I would do for anything is, of course, write my equation that I would need for this. And so the equation that I need is, of course, the Q is equal to C delta T. And the question that's being asked is just about heat capacity. So if it's just heat capacity, I need C. I don't need the specific heat for this. So then I look for what I'm calculating for, which I'm calculating for C. So C then is equal to Q over delta T. Then all I have to do is look for the information in my question, and Q is equal to 629 joules and delta T is equal to, remember, it's final temperature minus initial, so 145 minus 22 degrees Celsius, which is 123 degrees Celsius. So then all I have to do is plug that in my equation. C is equal to Q over delta T, which is 629 joules over 123 degrees Celsius, and that is 5.11 joules per degree Celsius. Okay, and make sure you keep the significant figures. Okay, I'm going to make this one decimal point here so that we have at least 2 there, and then if you want you can round it up to 5.10. But anyhow, this is how you would do the calculation for a simple problem. Let's look at another problem now. Okay, and in this one we will talk about how much heat is in kilojoules does it take to raise the temperature of 225 grams of water from 25 degrees Celsius to 100 degrees Celsius. So now we have to calculate for heat, and now in this case what we're going to do is we're going to use the specific heat also, okay, for water. So our equation that we're going to use is almost similar to what we did before, but now we have the mass also given to us for water, so we'll use the specific heat and of course the delta T. So then we have to make sure that we have all our data, and we have the mass. Mass is 225 grams. Specific heat of water that you can find from the textbook is 4.18 joules per gram per degree Celsius, and then the delta T that we have is going to be 100 minus 25, which is 75 degrees Celsius. So that's going to be our data. So all we have to do then is plug that into our formula. So mass 225 times 4.18 joules per gram per degree Celsius. This is grams here, and then 75 degrees Celsius. And then our answer after all of this calculation is 7.05 10 to the power of 4 joules, which is equivalent to 70.5 kilojoules. Now the question was asking in kilojoules as well, but we can answer whichever way we want. Okay, so depending on if the question is asking for kilojoules, give it in kilojoules. You can always cross out your units to make sure that you have the right units. And remember, whenever you're using specific heat and you're given joules over here, make sure that everything else also is going to be in the correct units. Here also grams, then this should also be grams. So keep your units in mind, always. Third problem, what will be the final temperature of a 5 gram of silver ring at 37 degrees Celsius, which gives off 25 joules of heat to its surroundings? So we ask for the final temperature, which if you remember, delta T is T final minus T initial. Okay, so that's where we have to go to the T final. And then we are given the specific heat of silver. So the way we get started is the same way, which means that Q is equal to ms delta T. But now we are calculating for delta T. So delta T is equal to Q over ms. And you can just go ahead and do cross multiplications. That works really well in this case. So then Q here is going to be 25.0 joules, and that is divided by the mass of the silver, which is 5.00 grams, and then the specific heat, which is given to us, 0.235 joules per gram per degree Celsius. So joules and joules, grams and grams, they all get cancelled out, and so delta T then is equal to minus 21.3 degrees Celsius. And why did I put minus over here? Okay, why did I do minus? And minus is because this is the amount of heat that is giving off to the surrounding. Okay, so this means it is exothermic. All right, so you have to have the minus there, and this will be helpful when we do the second part, which means that this is our delta T. Okay, so 21.3 degrees Celsius, and it's going to be minus, and that's helpful, and then T final minus, and T initial that's given to us is 37.0 degrees Celsius. Okay, now remember, this is final temperature of a silver ring which has given off heat. So if something has given off heat, then it means that the final temperature should be lower than what you started with. Okay, and so minus 21.3 degrees Celsius, it kind of helps you keep track of your data, okay, and your answer also, to make sure you're working on the right path. So then you bring the 37 on the left hand side, and when you add these two up, you should get a temperature of 15.7 degrees Celsius, and that's the T final, and that's your final answer also. Okay, so just remember that when you have an exothermic reaction going on, you're going to go ahead and make this as a negative over here, all right, because that's the amount of heat given off.